Hello and welcome to Monday's edition of Cracking the Cryptic, where Mark's just sent me this puzzle and suggested I have a go at it. I've read the rules, and this is quite mathematical, I think, in a way that might well not suit me. It's about quadratic equations, and I think I'll have to explain it, but basically every quadruple is like two solutions to a quadratic equation and then two of the coefficients of the digits in that equation. If you're mathematical, this will be completely easy for you. But for me, I doubt it will be. It's by a maths professor. It's by Dorlir. So I can well believe it's going to be a brilliant puzzle. But I'm not sure I can remember my equation for how to solve quadratics. This might be a very short video. Anyway, so I should hurry swiftly on, because if I just can't do it, I can't do it. What else can I tell you about before we read the rules to Dorlier's new puzzle? I can tell you. I've been beaten up today. I've just been doing the Minutecryptic. I won't tell you how many minutes my Minutecryptic video, which is meant to last a minute, was, but it was many more than 1 minute. My goodness, that was brutal. Anyway, that'll go live on the channel tomorrow at 2 p.m. We are streaming tonight, Blueprints, so I hope to see some of you there. We've been loving our trips to the strange and mysterious mansion. And at 10 o'clock tonight, that will continue. I'll try and remember to put a link on the screen to that. And then, I did want to, the last 2 days, I actually had something on over the weekend. So I couldn't record on Saturday or Sunday. So those were pre-recorded videos, which meant I didn't get to do the final tally for Duality 3, which was this month's competition over on Patreon. I mean, it's still there now. So if you haven't tried the puzzles, do have a go. They're fabulous things. But we should look at what the final tally was, shouldn't we? If we read it, 472 it was where it was, 507. So more than 500 people solved all 19 puzzles. That's just fantastic. It really is. Many congratulations to all those of you who managed to submit an entry. We'll draw the winner in the next day or two and announce it on the channel, and give one of you the opportunity to come onto the channel and do some solving. So I hope that might be of interest. Now, what else? Birthdays. Let me look at my list of birthdays. Now, because the last 2 days were pre-records, 3 of the birthdays are late birthdays. Many apologies. Jack, you turned the big 30 yesterday, I think. I know this because your best mate Luke wrote to me and says you're an all-round top bloke. And I think he means that unironically. He genuinely thinks that. And I know you're starting a new job soon. Machine learning at the speed of light via lasers. That sounds quite straightforward. Good grief. And you've been earning your pilot's license. Well, if you've been learning or earning your pilot's license, you haven't got it yet, so you can't be the maverick who plagues me. Yes, don't be a maverick, Jack, when you do get your license. But I do hope you had a great birthday yesterday. Many happy returns. I hope the cake was very splendid. Next, this is also for yesterday. Young Martin. Martin, you turned 7, and I know this because your mummy, Yao, wrote to me. And I think I remember saying happy birthday. You've got an older brother called Simon, if I'm not mistaken. And I think that I said happy birthday to Simon a few months ago. So Martin, I'm thrilled to hear whenever I hear that we have young viewers who are getting into these puzzles. It is fantastic. I mean, I cannot tell you how delighted I am. And Martin, I gather there was going to be a late choice to be made on the cake between chocolate cake and chocolate chip mint ice cream cake. I think either of those is absolutely splendid. And Martin, I hope you had a brilliant birthday yesterday. Next, Mylena. This was also for yesterday. I had an email from, is it Daniil? I might be. It's like Daniel, but with 2 eyes. And I know it was your 25th birthday, Mylena, and I think both of you watch the channel every night before you go to bed. So thank you both for doing that. And Mylena, I hope you have a great birthday, or I hope you had a great birthday, and I hope there was some chocolate cake. And then finally, a birthday for today. Peyton, it's your birthday. I know this because your fiancée, Michelle, wrote to me. I know that the two of you have just celebrated your 8 years together. I think today is your 26th birthday. And I know you've got a huge love for games and puzzles. So Peyton, thank you for watching the channel. I think there is some chocolate cake in store for you. Michelle certainly seemed to allude to that in her message. Many, many happy returns. Right. That's all the news. I've now got to remember the limited amount of things I know about quadratic equations. You could literally write on the back of a thumbnail, actually like a real thumbnail. Let's read the rules of this together and see if this video is going to have to be abandoned swiftly. We've got normal Sudoku rules applying, so we have to put the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. Quads. Each circle contains 4 invisible digits, not necessarily distinct and to be deduced. These must each appear in the surrounding 4 cells. So, right, so there's 4 invisible digits. I mean, what? Okay, anyway, let's read the next rule. The next rule, I think, is going to be the sticky point. Quadratics. Of the 4 invisible digits on a circle, 2 of them are the 2 solutions of x squared minus ax plus b equals 0, where a and b are the other 2 digits on that circle. If the equation has only one solution, that digit is to be... Oh, that digit... It is repeated. Oh, that digit is repeated twice. Right. I mean that. Let's just stop there. Imagine I was a wizard. Imagine I was Terry Tao and I was a wizard at maths. It's pretty amazing, isn't it? That just I don't know how many circles there are there, but you can specify a unique Sudoku solution with that rule set. It's really weird. I think that's really amazing. So let's just check we understand. So around this circle, there are 2 digits that are going to be a and b in that equation. And there are going to be 2 other digits that are the solutions to that equation using that a and that b. And if the equation has one solution, that digit is to be repeated twice. If the equation has only one solution. This is actually pretty terrifying, I'm afraid. I'm just going to crack on with this because I fear I may be turning the video off very quickly. Do have a go yourselves. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, okay, I vaguely remember, but I'm not sure I remember exactly what the quadratic equation thing is. I've got 2 ways of approaching this, and I don't want to do that way because I fear I may get the equation wrong. When I was at school, I think the equation... Oh, I don't actually know. I'm now going to say it wrong and everyone's going to think I'm daft. It was something like minus b... Oh, but this is going to really confuse everybody because the way I've remembered the equation is... oh, dear. As if a was... can I do little letters? No. So if you had a quadratic equation whose coefficients were a, b, and c, i.e. this was a times x squared, this is b times x, and this is c times 1, then I think the equation to solve that was minus b plus or minus the square root of b squared minus 4ac over 2a, perhaps? I don't even want to think about that. The other thought I'm having, though, is that I do remember that the way I used to solve quadratic equations was not doing that. I used to multiply the coefficient of the x squared number by what's the b number in this equation, and I knew that the solutions to the equation had to multiply together to that number and sum to what in this equation is the minus a number. So that's how I used to solve them. I just used to do a little bit of arithmetic. I used to so let's just think that through. In this equation, that means I think, and I'm going to test this as well. I'm going to try and think of an example, and we'll see if it's right. So I think what you do to solve a quadratic equation is in this example, you multiply b by 1, that's just b, and the solutions have to multiply to b, and the two solutions should sum to minus a. I don't really know how to think about this. So let's just put b equals 5. So if b was 5, what would that mean? Then I would need two Sudoku numbers that multiply to 5. Well, there's only 1 and 5. And then 1 and 5, the sum. Why is it minus a? Yeah, so if a was 6, then mine. Yeah, that's okay, isn't it? So if a was 6, whoa. So okay, now we need to think about whether this is true. So if there was an equation that was x squared minus 6x plus 5 equals 0, x squared minus 6x plus 5 equals 0, x squared minus 6x plus 5 equals 0. Are the two solutions to that x equals 5 and x equals 1? If x equals 1, you've got 1 minus 6 plus 5 equals 0. So that does work. But if x equals 5, you've got 25 minus 30 plus 5 equals 0. That's bizarre. Okay, so my maths memory is not letting me down there, which is rather surprising. I'm actually now going to check whether my memory of the formula is right. So what did I think it was? Minus b, which would be, oh, but this is all the wrong way round. So that would be minus 6 plus or minus the square root of b squared, which is 36, minus 4 times, so the square root of 16, so that's 4, all over 2. I think I might have gone wrong with my pluses and minuses there, because that only seems to have negative solutions. Minus b. Oh, but is that minus? So that's plus. So that would be plus 6. Yeah, that works. That's bizarre. So my knowledge of the equation has worked. Because I've got 6. Sorry, I'm getting excited about lunacy things. But 6 plus or minus 4. So that's either 10 or 2 divided by 2. So 5 and 1 are the solutions. Oh, okay. Right. That's great. That's great. That's pleased me. So how do we solve the puzzle then? I've got no idea. Well, no, that's not fair. I've got more idea than I thought I've got. So now... So there must only... Right, what's going to happen here is there's only going to be a limited number of possibilities, aren't there, for integer solutions to this thingy. Now, how are we going to find that? So if b was 1, it won't work. There are no solutions if b equals 1 to this equation. No. Well, there's no sudokuable solutions, I don't think. Because the only way of making two numbers multiply together to give 1 would be if they were both 1 themselves. So then I'd have to put 3 1s around any quadruple, and I can't do that. Sudoku will stop that. So b equals 1 has no solutions. b equals 2. 1 times 2 is 2. So one solution is going to be, okay, 1 times 2 is 2. So if b equals 2, so b is one of the digits. So we'd have 1 times 2 equals 2. But then I'd have to add, to get my a number, I have to add 1 and 2 together to get 3. So there is one solution if b equals 2 is what I'm going to claim. I'm sorry, and I know I'm being very dull here, and I do apologise, but I just want to think whether that makes sense. So I would be saying x squared minus 3x plus 2. Yeah, I can see 1 is a solution to that, and is 2 a solution to that? So if 2 is a solution, I'd have 4. 4 minus 6 plus 2. Yeah, that does work. Okay, so that is right. Okay, I mean, sorry, I'm sorry if everybody, I'm sure almost everyone watching this video is completely au fait with this. Okay, but I'm not. So now, if b was 3, there's only one way of multiplying two Sudoku digits to 3. So it'd be 1 and 3 and 3. And then 1 plus 3 is 4. So that is a collection of solutions. Or what I'm saying is 1, 3, and 3, 1, 3, 3, 4 could appear around one of these circles, but obviously not that one, because you'd have to, in fact, 1, 2, 2, 3 couldn't go around that one, because that one needs 4 different numbers around it because of Sudoku. No, let's keep going. 4. Ooh, 4 is going to be harder. I can immediately see that. Because we're going to have 1 times 4 equals 4, and 1 plus 4 is 5. So that's a set of solutions. But then I could do 2. I could do 2 times 2. There's no... So 2 times 2 equals 4, and 2 plus 2 is equal to 4. So 2, 2, 4, 4 is a possibility. That feels slightly more ridiculous, doesn't it? Now 5 is easier, I can see that. That's going to have to be 1 times 5 is the only way of making 5, and then 1 plus 5 is 6. And then 6 is going to... 6 has got 2 ways, I think. So it could be 1 times 6 equals 6, and 1 plus 6 equals 7. Or it could be 2 times 3 equals 6. And 2 plus 3 equals 5. So 2, 3, 6, 5. So that one is the first one which hasn't had a repeat. So that could go there. 2, 3, 6, 5. I'm going to remember these either. So 7, there's only one way to multiply it. 1 times 7 is the only way to make Sudoku numbers multiply to 7. So 1 times 7 equals 7. 1 plus 7 is 8. 8's got at least 2 ways to multiply it. It could be 1 times 8 equals 8, 1 plus 8 equals 9. Or 2 times 4 is 8. And then 2 plus 4 is 6. So 2, 4, 6, 8. It's never too late. That's not got a repeat in it. So that's distressing. So there isn't only one way to fill that one. 9. 1 times 9 won't work, because 1 times 9 equals 9 is fine, but then you've got to add the 1 and the 9 together to get your A digit, and that's going to be 10, and I can't write 10 into a cell of this Sudoku. So 9 could be 3 times 3, could it? 3 times 3 is 9, and that would go with 3 plus 3 is 6. So I have got 11 solutions to the equation. That is much more than I was hoping to get. Oh dear. Now, hang on, but some of these might not work because of Sudoku. Is that true? Like that one, 2, 2, 4, 4. I mean, I suppose it's possible. I mean, you could do it there, actually, couldn't you? 2, 2, 4, 4. Probably is that. But so, okay, so what can we deduce about this collection of solutions? A lot of them have 1 in them. Most of them have 1 in them. All but 4 have 1 in them. The ones that don't have 1 in them, they're sort of related to squares, aren't they? Like 2 times 2 equals 4, 3 times 3 equals 9. None of them have 2 ones in them. Two of them only have no repeated digits. Yeah, that's probably where you start then, isn't it? So 2 of them only have no repeated digits. So they are going to be difficult to place because, well, yeah, they are actually. There's more than this one, isn't there? That one can't have a repeated digit on it, but that one can't either. That one can't either. That one can't. No, that one can. 1, 2, 3, 4. There's one there. 5. So all of those, I think, have to be filled either with 2, 3, 6, 5 or with 2, 4, 6, 8. So they have to have 2 and 6 on them, all of those. Okay, I mean, obviously I can't solve it with all of this nonsense in the grid, so I'm going to have to get rid of this, but I just want to try and inculcate into my brain some of these. So if it has a 1 on it, it's always something like, it's always got a repeat. Yeah, is that something we can always say? Does 1 always have a repeat? Yeah, 1 always has a repeat. 2 doesn't necessarily have a repeat. 3 doesn't necessarily have a repeat. Oh, no, 3 does have a repeat. 3 does have a repeat, that's wrong. Because either that's 3. Oh, no, 3 doesn't have a repeat there. Oh, bobbins, I don't know. Okay, all right. I don't know how much more I'm going to get from just staring at those. I can't really see a pattern. I can see that 1s occur a lot and always with a repeat. I can see I think it's going to be the no repeaters that we're going to have to keep track of. So 2, 3, 5, 6, 2, 4, 6, 8. Right, let's do it. So this, and this all have 2 and 6 around them. And that's immediately quite interesting. Because, okay, How many 2s are there in row 1? 1. How many 2s are there in row 2? 1. But I know there's a 2 around there, and I know there's a 2 around there. So that's 2 2s, which are the only 2 2s that ought to appear in rows 1 and 2. So you can't have 2s in here. The same logic applies for 6s. So I've already got a 2-6 pair here. That's brilliant. Not of me. That's just brilliant setting, isn't it? Oh, okay, so 2s and 6s have to go down in column 4 in these 3 cells as well, probably around the funny old thing here. Imagine being clever enough to set this. Dorlir must just understand quadratic equations in a way that I am wholeheartedly demonstrating I don't. Oh dear, what do we do now? Okay, here's another point. This variation of quadratics is different from that one, because imagine both of these were the 2, 4, 6, 8. Then where would you put 2, 4 and 6, 8 in row 3? You'd have to put them all in those 3 cells by Sudoku, and you can only put 3 of them there. So whatever flavour of non-repeating quadratic solution goes in that 2 by 2, this one is different, and the same is true there. So actually these two are the same variation, we can tell now. Because whatever this is, let's just make that the purple variation. That's different from this and different from that. So the green variations are these. Okay, I don't know what that does, I'm afraid. Oh, wait. No, I do. No, I've got something wrong here, haven't I? Why have I put 2 and 6? Yeah, no, that's right. That is right. No, it's okay. Sorry, I was thinking I must have made a logical error, but actually it's true that they all do have to be different. So 2 and 6 does have to be around here. So actually, hang on. These digits then are they're either 4 and 8, or I want to say 3 and 5. I'm just going to check the 3, 5 one. 2, 3, 5, 6. Yeah, that was multiplying together to give a B of 6. So 2 times 3, and then add 2 and 3, you get 5. So that is right. That is a solution. So this pair is either 3, 5 or 4, 8. But okay, so all of these have a limited number. I mean, okay, so what I'm now realizing is that each of these quadruples, I won't do it, but if I was to fully pencil mark this quadruple, it would be the digits 2 and 6, and then either 3, 5 or 4, 8. So I think the point is we should ask in this row, where do 1, 7 and 9 go? Because they can't go into these quadruples. So 1, 7 and 9 have to go into these cells. And 2 of them are on this little thingy here. Now, 9 and 7. Am I wrong about this? I was going to say 9 and 7 don't go together, but now I'm questioning myself. I don't think 9 and 7 were in any of those options we looked at. 9, I remember, went 3, 3, 6, 9. That was a possibility. And there was one other that was, I'm going to say 1, 8, 8, 9. So 9 and 7 are not a solution. So one of these is a 1. So this is not a 1. It's either 1, 7 or 1, 9. Now, 1, 9... No. Oh! 1, 9 doesn't work. 1 9 doesn't work, because if it remember, if we do 1 9, if we have 1 on a thingy, which we do, we have to have a repeated digit. That's one of the principles that we worked out. Now, what is the repeated digit if one of these is a 1? The repeated digit's either 7 or 9. Now, if it's 9, then the way that the equation works is we've got 1 times 9 equals 9, and then the other solution is the 1 plus the 9, which is 10, which won't work. But yeah, and the other thing I've just thought of is 1889 is a possible foursome, but that won't work because this would be 88. So this is 1 7, and the 7 is the repeater. So there's a 7 in one of those. Oh, it's 7 and 8, isn't it? So it's 1 times 7 equals 7, and 1 plus 7 equals 8. So this is... Right, so I've got a digit. That's a 9. That is a 9. Okay, that seems to have done almost diddly squat, but... oh dear, naughty Simon. Is it this one? It might be. Or is it that one somehow? 1 and 7. 7 and 8. That must be a bit interesting. So there are 2 7s around that quadruple. So there are no 7s in any of these cells, because the 2 7s now, there's 1 7 in column 3, there's 1 7 in column 4, and the 2 7s are in that 2 by 2. No 7s here. So yes, okay. So 7 is in one of those 3 cells, definitely. So this quadruple, Maverick has taken off actually. Right, this quadruple has a repeated digit on it, I think. Because we know that if foursomes in this puzzle don't have a repeated digit, they are either 2 6 with a 4 8 pair or 2 6 with a 3 5 pair. But that's not going to work because these two can't be 2 or 6 by Sudoku. So these two would have to be the 2 6, and these two would have to be either 3 and 5 or 4 and 8. But that won't work because these are also 3 and 5 or 4 and 8. So these two digits would be the same because this little thing would be the same as this little thing. That cannot be true. So there is a repeat on here. Now, so most of the repeats involve 1, but there were options that don't. Right, one of the options definitely doesn't work. I remember there was a 2 2 4 4 option. Now that requires us to put 2 2s around there. You can't because neither of these can be a 2. The other option that didn't have a 1 on it was 3 3 6 9. Now I can see those. That can't be 9. Because if I fully pencil, I'm going to actually just do this because I think it will make it clearer. 3 5 4 8. I mean it's lunacy. Okay, but let's just go with the lunacy. So this can't be 9 because it's part of a foursome here that is either 2 6 3 5 or 2 6 4 8. So 9 does not live around there. This can't be double 2 4 for the double 2 double 4 for the reasons we said. So it does have a 1 on it, and that has to go here. And now the repeated digit is those 2 digits, which means that this digit is not a 2 or a 6 now. So that, let's just get rid of that. That's 3, 4, 5, 8. And this digit will be the sum of 1 and the repeated digit. That's the way it worked, isn't it? So it's like when we had 5 as the B digit, we worked out that 1 times 5 equals 5, and the A digit was 1 plus 5, which was 6. So when you put 1 as a solution, or 1 not as a solution, yeah, it is a solution actually. When 1 is the solution to the quadratic, the repeated digit is B and the other solution, and the A digit is the sum of 1 and the repeated digit. So we can't put 8 there, because this can't be 9. You could put 5, you could put 4, and you could put 3 apparently. Oh, that's distressing, isn't it? So that really... Okay, but if that's not 8, that's not 4, because we know around this one, yeah, we know around this one it's either 4, 8 or 3, 5 as the collection. So those two. Well, hang on. There's more we can do here. Because whatever this digit is, it gets duplicated there, is what we said around this quadruple. Now that means that this version of solution, which is going to be 2635 or 2648, is the same as this one. And that means that this digit, which is not 2 or 6, is the same as that digit, which is now... So those two are the same digit, which means that one is 3, 5 or 8. It means it is not 2 or 6. So this is the 2 and the 6. This is not... It's not 2 or 6. This is 2 or 6. Whoopsie. And these are the same, and these are the same. And... Oh no, I thought I was going to get that from that, but that's... I haven't resolved it, have I? Good grief, how long have I been going here? So I've only been going 37 minutes. That's not so bad. So hang on, what's that then? That can't be 2, can it? I thought when 2 was involved in my maths... Oh, no, I'm wrong. No, I'm wrong. Because I can do 2 times something. Although that doesn't really work here. No, it's fine. This is good. Yeah, remember what we just said? We said this was the sum of 1 and 1 of these digits. Well, this has got to be 6 then. Just by our earlier logic. I just didn't grok it. So this is 5. So this is a 1556 quadruple. So the equation associated with this is x squared minus 6x plus 5, and that has the solutions of 1 and 5. And then this is a 3. That's a 3, because we know that this is not the 2468 variant. This is the 2468 variant. So this is the 2648 variant. That's not 2. That's not 6. That's a 4-8 pair. So this is a 7. That does my 7s. That does my 1. That does my 8. Oh my goodness. Come on. 149 into these cells, I think. And that is not a 1. Seven is in one of these two cells by Sudoku. 3. This is a 3-5 pair by Sudoku, so that digit is 9, I think. That's a 4 then. So this is a 1-9 pair, and this, no, I must know that digit. That's a 4 by Sudoku. So those two digits at the top there are 7 and 8. The Sudoku does seem to be behaving itself, which is always something of a relief. Now, is it this one? I don't know. Sorry. Just let me think about this for a second or two, or perhaps even 3. So this, that could have repeated digits on it, but if they were repeated, it would have to be those two, because this can't be. Well, there was no solution that had double 9 as part of its options, and you can't double 1 because of this. So if this does have a repeat, well, hang on, it must have a repeat. That's it. It's very straightforward. Yeah. So if we look at this collection, we learnt earlier that there were two possible solutions that had all 4 digits being different, and they were 2, 6, 4, and 8, or 2, 6, 3, and 5. Well, this digit's definitely not one of those. So this is a foursome with a repeat, and for the reasons I've just said, that diagonal hasn't got the repeat. So this diagonal does have the repeat, and 6 can't be there for some reason. Why? Oh no, that's true. By Sudoku, it really can't. So that is double 2, which can't go with 9. I think this is going to have to be a 1, and this is probably a 3. Yeah, I mean, that's just true from our panoply of solutions that we worked out earlier. And then this is going to be a 3. We've sort of worked it out here. The repeated digit, you add the 1 to it to get the A digit, if you like. So, okay, let's carry on going now. Now there is definitely, oh, that doesn't matter. I was going to say there's definitely a 6 in there, but that's probably not the critical thing. Aha. But this is now not got 3, 5 on it. So this is 2, 6, 4, 8. The 4 is not there. So there's a 4 in one of those. So there's a 4 down here by Sudoku. There's an 8 in one of those. So there's an 8 down here by Sudoku. 2, 4, 6, 8. There is a 1 in one of these by Sudoku. In fact, there's a 5. This is a 1, 5 pair purely by Sudoku. This is a 7, 9 pair purely by Sudoku. So the bottom of column 7 is 4, 4, 6, 8. This is a 6, I suppose, because we've finished this off. So that's not got 6 on it there. So it does have 6 on it here. Does that make sense? Probably it does. There's a 4 in one of those. Oh, hang on. What's going on in those cells? I've got lots of even digits. 2, 4, 6, and 8. So the 2 in this sequence has to be on the right, look, because it can't be in these. So these 2 digits are not 2. And I don't know if that means more. It could do. Otherwise, what we're going to have to... it's probably that one, actually. It probably is this one. I'm just a bit scared of it. Could it have a 2 and a 6 around it? Possibly, actually. If that was a 2 and that was a 6... But then that can't be a 4, 8 or a 3, 5 pair. So this has a repeat on it. Is it the repeat that involves a 1? Maybe. Could be 1... Yeah, it could be 1, 8, 8, 9. If it's not involving a 1, it's 3. Yeah, it was 3-3. Maverick is buzzing by, sorry. 3-3-6-9 was one of them. I can't repeat 3 on that foursome, so that's not right. And it can't be 2-2-4-4. So this does have 1 around it, and I can put that in. So that's 1, that's 5. And now we know that these two repeat, and they sum, and whichever the repeated digit is, you add 1 to it to get this digit. And I can't repeat 6, so this can't be 7. This is 9, this is 8, this is 6. This is just... I know it's quite mathsy, this, but I just find this mesmerising. I really do. I'm also going to be intrigued to see how many of the comments are ridiculing my inability to remember high school maths. It's just, actually, this is a sort of puzzle. If I'd come across this as sort of a 14-year-old child, I would have loved this. I know that makes me sound very sad indeed, but I really would. And it's totally it's probably more doable by a child of that age than it is by me, because you wouldn't have to remember. Look, that's an 8 now by Sudoku. So this is a 6 by Sudoku, and that is a 4 by Sudoku. Yeah, because you wouldn't have to remember the formulas, you just know them. They would be innately part of your being. 4, 8, 6, 4. Okay, so now I mean, it's remarkable, isn't it? So somehow, some way, these 4 remaining circles are going to have to do the business here. This digit is a bit... That does see 7 different Sudoku digits. That's only 5 or 7, I think. Okay, let's look at this one. It doesn't have a 2-6 pair around it, because neither of these can be 2 or 6, and that can't be 2 or 6. So it's not capable of being a no repeater. So there is a repeated digit on this, and that repeated digit is either those 2 or these 2. Now, if it was these 2, it would have to be 5. And then we know it would be a 1. That could work. I was going to say we'd know it would be 1 and 6, but the 1 could go here and the 6 could go here. So we can't rule out that this is the repeater. Right, let's try and rule out whether that could be the repeater. If that's the repeater, what can it be? It can't be any of those digits. So it's 1, 5, 7, 8. It's not 8. It's not 1. What? Hang on, 1? So it would be 5 or 7 again. Oh no, it can't be 7. Oh, so hang on, that's weird. So is it always 5 that repeats on here? I don't trust that at all. I don't trust that at all. Let's just recapitulate that logic. 1, 5, 7, 8. So 1 is clearly impossible. 8, so 5 or 7. So it would be a 5 repeating into these 2 cells. But then we know we need 1 and 6 as the counterbalance, and they don't work. So I don't think that can work. I don't think this is the repeat. I think this is the repeat. 7 can't repeat, so it's a 5 repeater. And we know that once you've identified the repeater as 5, you're not looking at the 3-3-6-9 or the 2-2-4-4 variants. So you're looking at a 1 variant. Well, that has to go here with a 6. I mean, that feels logical to me. That's now not a 5. What about this box then? What do we need? 3, 7, 9. No, that's fine. That's a 7. That's a 3, that's a 9. That box has been completely finished, which is a total bonus. I get a 1-2 pair at the bottom of column 4. I get a 7-8 pair at the bottom of column 5. I get something here, which is going to be 3, 4, 9. Now, what is my Sudoku going to do for me? And the answer is absolutely diddly squat. But we have got a 6 on this one. Now 6. Well, okay, 6, 6, 2 is what this is going to be, isn't it? Because this could be a 2. It's going to be one of those funny ones where all the digits are different. Yeah, it's quite interesting, actually. Imagine this wasn't a 2 for a second. If this was a 1, we know 1 always has a duplicate digit on the other diagonal. So it would be double 6 here with a 1 and a 7, and that's going to break. So this is a 2, this is a 1, this is a 2, this is a 9. And then we know that these two digits are either a 3-5 pair, which is going to be a 5 and a 3, or a 4-8 pair, which is going to look like that. And that's very distressing, isn't it? Because that doesn't seem to be... I mean, there's probably some Sudoku we can do here. Let's see if Sudoku is going to get us out of a pickle. This is a 5. Oh, well, that's very useful. It's immediately unpickled us, because this being a 5 is now looking at this, which can't be a 3-5 pair. So that's got to be a 4, that's got to be an 8. Let's see if we can tidy up some stuff from that. In this column, what do we need? 2, 3, 6. That's a 6 naked single. So this, and that's a 3, so that's a 2. Oh goodness. Oh, let's look at that. That could be double 2, double 4 perhaps. But anyway, let's just carry on up here for a moment. 7, 8 here. 8, yeah, here we go. 8, 7. 3, oh, no 3 in the corner today. So it is this one, I think. Well, I remember that double 4, double 2 was an option, which looks like it will work. If it's not that, it would have to be 2, 6, 4, 8, which won't work, because this won't work. We've already got our 4. Or it would have to have a 1 on it, and these would be a repeat, and that should be 1 plus 4 rather than 2. So it is, this is 4 here and 2 here. And that's 3, and that's 3, and that's 5, and that's 4, and that's 8, and that's 8, and that's 7, and that's 2, and that's 6. Come on. 1, 5, 9 in the column. Okay, so this is 1 or 5, this is 5 or 9. And this row, 3, 7, 9, 7 or 9. Can't quite see how to do the Sudoku here. Right, what do we need in this column? 1, 6, 7, 9. So that is 1 or 6 only. Which is... that can't be 9, I've just seen. 3, 4, 9. What's this corner digit? That corner digit is 1, 6, 7, 9. So it's not. So it's 6, 7, 9. No. Oh dear, don't be mean. Hang on, I just can't see it. It's going to be... oh, this would be just disastrous if I can't solve this from here. I mean, I think I've done the maths, which was the thing I was most worried about. 5 has to be in one of those two. I'll just pencil mark it. I'm not sure. It's probably some sort of triple, which I want to say in this row. 1, see, 5's got 2 places, 6 has got 2 places, 3 has got 2 places, 4 has got... see, everything's got 2 places. Bent triples, then. Let's look for bent triples. We could look for 1, 5, 9. 1, 5, no, nearly, but not quite. Oh, goodness, sorry. I probably am just missing very elementary Sudoku. That is not normally happens at points like this. So let me just... The thing is, I've actually pencil marked every cell. It's possible I haven't removed something I should have done. 4, 5, 6, 7, 9. 4, 5, 6, 7, 9. 4, 5, 6, 7, 9. No, okay, it's not. It's something more complicated then. It's going to be some sort of bent triple, and I just can't see it. 1, 5. I keep thinking it's going to be 1, 5, 9. Like, no. Okay. 7. Yeah. Okay. Well, I've got something. It's more complicated than I thought it would be, but it's a bit of a bendy triple. Those 3 can be bent. So you can see those digits are 5, 7, and 9. They're the only options for them. But the critical thing to look at is this cell. Now, if that cell's 5, this cell's 7. And if that cell's 9, this cell's 7. So you know that one of these, let's choose a new colour, one of these indigo cells is definitely 7. They might both be 7 in the finished grid, but that definitely one of them is. And they are both looking at that one. So that is a 3. That's a 9. That's okay. So that is a 7. This is a 5. That's a 7. So they were actually both 7 at the end of the day. But that being 5 is doing some work. That's 1. That's 6. So that's 1. That's 9. And now I should know that digit, which is 9. So that's 5. Yeah, I think it's falling over now. 3 and 4. What a puzzle that is. It must be right, mustn't it? It must be right. It felt like it was right. That is absolutely stunning, Dorlir. I mean, just... Do you know what I mean? If you were at school and presented with that, I really think, you know, somebody who's interested in like exploration and puzzles and maths and things, they would absolutely love that. I found that that's brilliant. It's brilliant. That's as fun an hour of puzzling as you could possibly have. Loved it. Let me know in the comments just how inept I am at maths, and we'll be back later. No, I do enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.